All right, with great data comes even greater access latency. Welcome to the Presto Community Broadcast, where we transform your latency woes into fast insights. I am Brian Olson,
I'm Manfred Moser.
and we are also joined here today by a very special guest, Martine. Welcome.
Hi, Brian.
Presto Community Broadcast, the show where we cover events and happenings within the open source Presto community and show off some cool stuff about Presto, and also have a whole bunch of technical difficulties with our sound. Today we're going to be covering a lot of pretty neat stuff. So in this whole series where we've been kind of building up to dynamic filtering, which is kind of a big subject onto its own, we wanted to cover a lot of smaller topics. So in previous episodes, we've covered Hive partitioning. We've covered just to basically get an understanding of partitioning in general. Last episode we were covering planning and kind of some of the steps that happen to go from query into like planning. And then today we're covering more specifically on the cost-based optimizer. So cost-based optimizer is a very interesting subject. We'll jump into that and probably not get too far ahead of ourselves. We have a PR that's kind of related. It's about decorrelation from subqueries, so it's all within that kind of planning and optimizing mix. And then we are covering the question: does Presto make my RDBMS faster? So common question we get on the community side of things. Before we hop into any of that, let's go to our Starburst advertisement, and we'll be right back in a sec. I'd like to take a moment to thank our sponsors, Starburst, for hosting this show. Starburst is an enterprise offering that builds upon open source Presto distribution. The main vectors you improve upon when moving to Starburst are performance, support, and simplicity to deploy. The performance gains come from an enterprise suite of Presto connectors that improve upon the open source connectors by offering parallel implementations and improved statistics exposed to the cost-based optimizer. There are also connectors that don't exist in the open source projects, such as the Snowflake connector and Delta Lake connector, and many other that prove useful in many enterprise applications. My favorite thing that Starburst offers is how they take away the pain of deployment, security, and scaling your Presto cluster up by offering Kubernetes deployments on multiple cloud platforms. This relieves a lot of pressure from your ops team and offers them a slick user interface called Mission Control that makes the management of your cross-platform clusters easy. Finally, they have a team of experts that are available to address any issues you experience. This team includes the original founders of Presto, a dedicated customer success team, and even Manfred and myself. We clearly think the product is great, but don't take our word for it. Try Presto for free. Head on over to starburstdata.com to learn more. And now back to the show. All right, so before we hop into cost-based optimizer, Manfred, we have release 348 this week.
Yeah, this time it got even closer to our identical timing that we have sometimes, right? Like it just was released like 3 days ago.
Yeah.
It kept going like, yeah, it's gonna make it. It's interesting how that all works out always, and I'm very happy that it did make it again. So
otherwise, we would have talked a little more about 347.
No. There's always so much going on.
Yeah,
we can always talk about ongoing PRs, but
sure.
That's a different story. No, like as Martin also announced, there's a whole bunch of pretty big features. We got OAuth 2 authorization in the web UI happening, so that's on the plan towards getting more and more single sign-on systems supported. For the web UI and in general also for other clients. That's now in. We got S3 streaming uploads working. Again, more performance improvements on the order by limit queries, and the distinct aggregation in correlated subqueries also works.
Nice.
What really blew me away is, and Martin can maybe tell us a bit more about that, is there were a lot of changes on the JDBC driver. What was going on there? Did someone just focus on this?
Whoa, holy crap.
Yeah, this is so since we added there's a couple of things here. We added support for variable precision datetime types over the past few releases, and there were some loose ends that need to be tied up. Specifically some edge cases around rounding and truncation of time. So that's one area of improvements. The other is so JDBC has this weird behavior when JDBC comes from a like all the way back to the first versions of Java.
Yeah.
And when dealing with datetime types, it uses the built-in types in the JDK, like date and time and so on. And those are notoriously problematic in terms of how they manage time zones, how they are stateful objects, they are mutable objects, and so on. So one of the things we've been doing is extending the API, the JDBC APIs, to be able to use the new Java time objects and classes that are available in recent versions of Java that are safer to use. They have more well-defined semantics. So that will make it possible for anyone that's trying to interact with Presto and extract datetime data to be able to do it in a much more reliable way.
So quick tangent on that. Like, so when you take the actual interface, are you converting those time types, like basically as they get sent in from the one that's being sent into like the JDBC interface? Is that how we're doing that, or?
So there's an encoding that happens when data comes out of Presto, and that's it uses a JSON-based encoding right now.
Mm-hmm.
That's independent of JDBC. So the JDBC driver sees that data, and then what it did up until now is it would try to convert it to the Java classes from the old JDBC specification, and what we added is the ability to convert them to some of the new types. Like, for example, if you look at, actually, let me look at the release notes here briefly.
You just tell me a number, which.
Yeah, for example, in the second line in the JDBC driver that says, oh, actually the first one that says, allow reading timestamp with time zone as zoned date time. That means that now when you have a JDBC result set, you can say, I want the value of this column using this specific type.
Okay.
And this is a new type. It's not covered by JDBC, but we allow you to get it using that class to be able to get more precise semantics and safer usage.
Very cool. So if you're like listening on the podcast, this is basically, we're talking about the JDBC API, and so they have this generic result set .get object class, and you can actually specify the class there. And so this is how it seems like we've circumvented that the old school date types, and now we're using the new Java time date types. Very cool.
Right. Yeah.
So with those changes to the new data API, have you like observed any performance kind of like changes as well? Like, I know that the old calendar class, for example, was super heavy to instantiate and a pain to carry around. And there were a lot of improvements when Joda time was adopted and then into the JDK.
I mean, we haven't measured it, and there might be some improvement. Well, I guess someone should take a look at that. In general, it probably won't matter much because the bottleneck for when dealing with JDBC talking to Presto is going to be getting data out of the server. Yeah.
Fair enough.
Cool.
Right, so that's what was in the official announcement, and then I have a few other things that I thought were kind of cool. So there's a new show stats command that you can go show stats for your query, which is just something that's not necessarily useful unless you like want to geek around and play and see what's happening, and that's always fun. So I encourage you to play around with that just to see like what like affects your query and a bit of the statistics of it going on. Another thing that is important for people that are on the bleeding edge and played around with the Hive translation, with the new Coral subsystem, there is a new property added that allows you to either switch the Hive translations off completely, use the new one, and that's also now possible to switch to the old legacy one. So we had some people that rely on some behavior of the legacy one. Some people rely on and really like the new one. So now it's possible to really choose between which one of those are important. So that's cool.
I want to make a comment on that. So originally, like Presto wasn't able to query Hive views because the Hive views use Hive syntax, Hive semantics. So there was no way to reliably do that. At some point, we said, okay, we're going to allow Presto to read those views and basically interpret them as if they were Presto queries. So this was a very straightforward, not very safe way to interpret the Hive views because, for example, you may have a view that says, I don't know, select from some table where and some filter that invokes some function that has different semantics in Presto than in Hive, and you would end up getting different results than if you query the same view from Hive. So, but we said, okay, this will make it easier or will enable some use cases, like people use Hive views just as a way to constrain the number of columns that are produced by a table, or doing some very simple filtering and transformation. So we said, okay, we're going to add this. It's going to be an experimental feature. People have to be aware that there may be safety problems or correctness issues in terms of you may get the wrong results, you may get different results than Hive, and so on. Mm-hmm. And with an eye towards having proper support in the future, I mean, we knew LinkedIn was working on Coral. We have been working with them, collaborating with them to eventually integrate that into Presto as a more principled way of doing translation of those Hive views into Presto. So when we finally integrated that, it turns out that, well, Coral doesn't support everything. So some things that people were relying on end up breaking. So we say, okay, let's introduce a flag to be able to restore the old potentially broken behavior just as a transition.
Okay.
And while we make the Coral integration and support more robust, at some point that will be solid enough that we'll be able to just get rid of that legacy flag, and then the implementation based on Coral will be the single and proper implementation for doing that.
The really cool aspect that I want to point out there, and that's maybe not something everyone in the community knows, is that you are very closely working with the engineers at LinkedIn on that Coral integration, and you're helping them find corner cases and like get them fixing it and so stuff. And I love that aspect of really working closely and getting for the benefit of both projects, basically. So that's really cool, I think.
Nice.
Absolutely. Yeah, this is a big, I mean, it's a community project. It's a big community and collaborative effort. So yeah.
How many engineers do we typically work with over on LinkedIn side? I feel like I've seen at least like 3 in the community kind of actively making changes.
I mean, they have a large, they have a team of, I don't know, maybe 8 to 10 people, I think, and it keeps growing. So
pretty cool.
I know not everyone is a developer on Presto. They of course have to support Presto on their own for their own deployment and installation. So they kind of split the time. But yeah, it's like they've been making a big investment in Presto, and they're growing their usage and their team.
Nice.
While you have it up on the screen there, by the way, there's a whole bunch of other Hive connector improvements again, as usual. Something that always seems to happen in every release. Is there anything specifically you want to point out, Martin? I think it's sort of like through the gamut, sort of like various ones. There's nothing that I thought really pointing out. What I did, however, think is it's really cool that the Iceberg connector, which is kind of related, now supports GCP and Azure. So there's really a bit of an effort going on there and getting that one up to snuff. So that's really cool.
I feel like the future, right? future Hive connector, and at least it won't be called the Hive connector. Cool.
Well, that Iceberg connector has come around pretty quickly recently. I think there's been quite a lot of development. It's gone, like David Stryker was working on it quite efficiently and like got lots done there, I think, and that was really good.
Yeah, that's another one that is there's a lot of interest from many organizations and people to be able to support the Iceberg more fully. LinkedIn has been making some investments. Netflix, of course, Starburst, and there are other companies like Amazon and Apple that are interested in making.
Do you have any connections?
A reality.
So, are you working with the upstream Apache project directly as well? Or?
We are. Yeah, we are. Yeah, there are a number of things that Iceberg is evolving, and there are a number of things that needed to be defined or were not well specified. And as we went through the process of implementing the connector, we worked specifically. David Phillips has been working with the Iceberg project to make sure that everything is properly specified, so we can.
That makes sense.
That.
We need to do an Iceberg show and just pull David on then at one of these times. It'll be a good one.
Probably. Yeah. And then the last one is, like as usual, there were like a small SPI changes, but that's only applies for people that implement their own connectors, but always useful to know about.
For sure. Cool. Well, do you have anything else you want to cover on the release?
Not on my end.
Okay.
349, here we come.
Yeah, that's right. I think one last thing to say before we hop into the basically the interview or the concept of the week is we do have a quick announcement about Data Nova. So I'll actually just say if you want to go to starburstdata.com/datanova. So go to starburstdata.com/datanova. It's a free event. There's 2 tracks. There's kind of a technical track that most listeners of the podcast will be interested in. I'm going to have a lot of speakers, basically anybody from data scientists to, Martine is going to be speaking as well within the group of Martine, Dane, and David. So, and then just basically a couple people that have, this guy here, Ahmad, is going to be giving a talk about building up the semantic layer at RBC, using Presto as their semantic layer over different data stores. So it's going to be a really cool, fun time, and still virtual as we kind of get hopefully closer to the end of this pandemic. But check it out and hopefully see you there and register for it. Outside of that, there's really not too many events or news to be reporting on now. So we'll hop right into cost-based optimizer. So I'm going to give a quick backup to what we had talked about last episode, just so that we can kind of build some context for anybody who missed episode 6. So basically, we were talking about the journey that a query takes from the time that you hit enter on the CLI or on your BI tool, whatever it may be, and how that query kind of transforms along the line of basically until we get to where we're talking to the optimizer, is where we stopped last episode. So just to catch you up, what happens is we have a parser that basically parses the string query that you have into an abstract syntax tree representation, and this is just a very useful syntax for what the next process, which is the analyzer. This analyzer can then make reasonings about these different identifiers. That's what we're calling it here, or you could say column identifiers, and verify does that column identifier actually exist, or is there any type of SQL issues that this database we don't have connectivity to it, things like that. The analyzer can actually verify that every column that's being referenced actually is not duplicated or having some specific reference that it's actually talking to. From the analyzer, once we've gone from this form of AST and analyze and make sure everything is syntactically correct and actually something that makes sense, then we move on to a planning phase. And so the planner is going to initially generate a plan IR, which is intermediate representation, and is basically yet another tree. But this tree is now trying to describe the way or the steps that we're going to need to take in order to execute this query. And so initially, a lot of things that may be even duplicated or just maybe something that can be simplified, the planner is going to initially come up with a plan that can remove some duplication and basically just get this initial representation going. And then we then go through various iterations, which will be running through rules that will be basically the optimizer. So at this point, I'm going to ask Martine to kind of basically correct me on anything I screwed up there, and then also kind of go over his version of describing the optimizer.
One thing I wanted to clarify. So you said the parser produces the AST, which is accurate. The job of the analyzer is to make sure that the tree, which is the syntactic representation of the query, is semantically valid. Mm-hmm. For example, if you have a group by clause and aggregations, the analyzer is responsible to make sure that for example, all the columns are in the group by clause or they are properly proper aggregation functions.
Cool.
If that's not the case, then it will complain with saying this column is missing in your group by clause or something like that. You also make sure that, for example, if you're comparing, if you're invoking a comparison operator, like you're doing A greater than B, you need to make sure that A and B are compatible with respect to comparison. For example, you cannot compare a number with a string. So you make sure that those types are compatible, or that there needs to, if there needs to be some kind of coercion between the to make that comparison valid, then it will determine that, and it will make a note of that, because that's information that the planner later needs to be able to produce that intermediate representation.
Very good. Yeah, that's way more eloquent than how I described it. Yes. Okay, so then we hop into the planner, and this is kind of where things, it's pretty clear that you have the AST that's generated by the parser, and then you do your syntax. You're basically checking the syntax using the analyzer. But then when you get to the planner versus the kind of optimizer phase, one of my kind of confusions coming in was like, if you are, where does planning begin and end, and where does planning end and where does optimizing begin when you're talking about the planner and optimizer? They're handling these kind of different variations of this plan IR and ultimately building up to the plan that you'll execute. But at what part are we talking about the planner, and what part are we talking about the optimizer, or are they the same thing?
Yeah, I think it's not a useful distinction to talk about planner versus optimizer. I mean, if you want to separate that, you would have to say that the planner is just the translation from the AST into the IR, right? It's just almost a mechanical translation. It's like if you have a from clause with a table, then that turns into a table scan node. If you have the where converts into a filter node, then a group by turns into an aggregation node, and so on. So that's kind of the planning step, but it's not very interesting to talk about it as a separate thing, because it's almost like a mechanical operation.
Okay.
When I talk about planner and optimizer, I always see them as part of the same thing. It's like the job of the planner / optimizer is to take the AST with all the annotations that the analyzer produce, saying this specific AST operation needs to have a coercion between here and there, and so on, or any metadata is needed. For example, this table references this specific table from this connector, and these are the columns that are available and the types and so on. So it's the job of the planner / optimizer to take that and produce a form of the IR that is executable and efficiently executable, right? So it does that by doing the initial translation to the IR, and then subjecting that initial representation through a number of transformations to make it more optimal. Like transformations could be, for example, removing duplicated operations, or pushing down filters because there's an expectation that filtering things early is going to result in a more efficient query. At some point, converting that initial representation, which is high-level logical representation, into something more physical that includes, for example, the choice of join types that are going to be performed. Are you going to do a partition join or a broadcast join? Are you going to have exchanges in the middle because you want to parallelize the execution of the query across multiple machines or across multiple threads? So all those are transformations that the optimizer performs based on an understanding of what operations are going to be more efficient than others and are going to lead to more performance or lower latency.
Cool. So there's in the book we describe like I should say you two describe your two of the authors right here. So you both describe kind of there's a logical segment of the query, and then there's like a time where it becomes a distributed query. And it's pretty clear roughly what that means is like you get the plan IR to a particular phase and it's logical, but then you have to actually, like rubber meets the road, you actually have to figure out, okay, like reasoning about how many workers you have versus how many sources you're pulling data from. Is this also part of the optimizer, or is this planner part? And is this, is when I say is it part of the optimizer, I should be more specific. Like, is this one of the phases of this planner optimizer, or is this going to be something that happens kind of afterwards in the scheduler?
And there are some things that happen during the optimization phase. Like, for example, the cost-based optimization rule. I mean, there's one of the transformations can take advantage of a cost model and in order to make decisions about the order of joins and the type of joins. One of the things it looks at is what is the number of workers that you have available right now in the cluster. And that's important, for example, if you're deciding whether you're going to do a partition join versus a broadcast join. Because if you happen to do a broadcast join and you have 1,000 workers, then one side of the query is going to be broadcasted to 1,000 machines, and that takes memory. So that plays a role in determining maybe it's better to do a partition join instead, because we use less memory. So there is that aspect of it, but it's not until execution time when the Presto engine makes decisions about which nodes are going to get assigned which piece of work, which parts of the plan to process, and so on.
Okay.
I mean that's not considered during the optimization phase.
Okay. But that's important to understand. Like when the query planning is happening, the number of nodes that are available is one of the sort of like fixed numbers that are taken into account. And the same, like one of the other things that influence what happens in planning is the actual information that comes out. So when we talk about cost-based optimizer versus just a normal planner and optimizer, what's very important to understand is in order for the cost-based optimizer to work, it needs to know not just about these are the tables, it also needs to have what's called table statistic information. So it needs to know that one table on the join is like a small lookup table versus a transactional table with millions of records, right? Like otherwise, if it doesn't have that information, it can't make the right choice. And maybe Martin, you can tell us a bit what those stats are that are important, that are taken into account mainly, and also where they come from, right? Like they come from the connector and are supplied by the underlying database. But what are some of those statistics that have a big impact, maybe?
Yeah, and one thing to want to comment on before is that one way to think about the cost-based optimizations is that without any knowledge, I mean, if the only knowledge you have is that you're going to have a certain set of tables involved in the query with different columns or a certain number of columns, the only decisions you can make are based on that information. It's like, well, you know that filters of this type are generally better than filters of if you do them early than if you do them later, so you always push them down. So it's like there's not much freedom you have in terms of making certain decisions of, do I transform the plan in this way or that way? When we talk about cost-based optimizations, we're saying, okay, if you get more detailed information about the tables, like for example, if you know how big they are, if you know something about the distribution of data in the tables, then you can use that to make finer decisions about, for example, if you're doing a join and you know one table is bigger than the other, and because of the way Presto works or how it performs joins, it's better to place one of the tables in memory and then stream and probe the other table. So by knowing that information, you can make slightly better decisions about how you're going to execute the query that you wouldn't be able to do if you didn't have that information. So some of the factors that come into play here are things like for every column, and this is something that Presto can look at. For every column, it can look at what is the minimum and maximum value, how many nulls or the fraction of nulls. For a row, what is the average size of a row? What is the number of rows that a table has? And then it combines that with a bunch of heuristics about how selective filters are going to be, how a model of how much memory one of the size of the join is going to take once data is loaded in memory. And then you can take advantage of that to figure out, okay, given all this information, I'm better off doing a distributed join or a partition join versus a broadcast join, or I'm better off swapping the order of these two tables, or if you have multiple tables, I'm better off ordering in this specific way as they get joined together. So those are some of the factors that come into play. And then based on those factors, there's again, it's an abstract model of based on those factors and the shape of the plan, how much CPU is going to be used, how much network data is going to be transferred over the network, how much memory is going to be required for operations like joins and aggregations and so on. And then all those are combined into one metric that allows the engine to make decisions about this order of joins is better than this other order of joins, and then it can pick one or the other.
How do you
and then of course,
go ahead.
Yeah, I was going to say, yeah, of course, those statistics about the minimum and maximum values, the number of nulls, and so on, need to be provided by the connector for the specific tables involved in the query. And different connectors have different strategies for how they collect those stats, how they manage them, and so on. For example, in the case of Hive, the stats get stored in the Hive metastore as part of the table metadata. Or partition metadata. It can be granular down to partition. In the case of Iceberg, they can also be at the table level, at the partition level, and Iceberg can store stats more granularly and eventually expose them to Presto as part of the query planning process.
Man.
Those stats are also typically like something that, like, I mean, this whole cost-based optimizer idea is something that's been around for quite a long time in like relational databases and stuff like that, right? So they all store that as part of their information schema, I'm assuming, right? Or have some process to get it there, right?
And
it's typically data is associated with tables, like whether it's part of the metadata or stored separately, that's up to like different databases implement them differently.
So also the mechanism to get them generated isn't always, like, I know from like writing docs on various connectors, it's always different. Like you have to just find out, is your system doing that automatically or not, or have to kick it off, and how often does it have to be refreshed? Because like some of those operations actually take time to find out, right? You just have to check how that works each time.
And how do we decide, if there's, when we're let's say introducing a new type of optimization, how do we decide that it's not over analyzing the, or it's going to add more, basically there's not going to be a good enough trade-off? Or have we ever considered an optimization and then we realize like in reality, like, or whenever we actually tested things out, things were actually slower because the optimization phase ended up taking more time and generally than the actual optimization itself? Has that ever taken place?
That generally doesn't happen. I mean, the optimization taking longer than the actual query processing, that generally doesn't happen. I mean, as we start focusing more and more on super low latency queries, it may become a factor. But then again, you're typically dealing with small tables with smaller queries if you're doing super low latency queries. So that tends to cancel each other out. Now we've seen there are cases where there's no one size fits all for an optimization. You may have an optimization that is good in some cases and makes things worse in other cases. There are, like, longer term, there are a couple different ways to deal with that. And in the short term, what we do is we say, okay, if there's no definitive way to go, it's like if we can't say that this is always better than this other choice, what we typically do is we add a toggle to Presto via either session properties or configuration, so that users have a way to fall back to the old behavior if the optimization introduces a regression for some use case. And then the idea is that with that we have a way to allow people to use the optimization, see how it behaves. If there are problems, we can look at it. We can see if there's tweaks we can make, there's changes we can make to make it better and satisfy more cases. And if there is just no other way, that we'll keep the session property for a while to allow people to have that choice. I mean, that's not ideal, but kind of a escape hatch if there are no other options. In the longer term, the idea is to make, so right now Presto does cost-based optimizations only for joint reordering and joint type selection. So what we want to do in the longer term is to make the entire optimizer be able to reason about cost. And there are, I mean, again, this is nothing new in database world. There's a lot of literature, like there's an architecture called the Cascades framework. There are frameworks like Calcite that do things like this, and this kind of the direction we're moving into is like making the whole optimizer be aware of cost and be able to consider multiple plans at a given point in time and explore different options. And in this case, like when an optimization is maybe good for some cases, but not in other cases, hopefully the ability to reason about cost will help us differentiate between them. But optimizers are also not a panacea. Like you can't produce a perfect plan for everything, because at the end of the day, it depends on exactly what data you're processing, exactly the shape of the plan, the operations you're performing. So you will need to execute the query to know which execution form is optimal. Yeah. So longer term, I think the solution to this is to do more integration between the optimizer phase and the execution phase, and make the execution more adaptive. Like there are some places where Presto is already adaptive in terms of execution. For example, you can start running a query, add more nodes, and the scan will spread out across more nodes that become available. And there are mechanisms for doing load balancing across machines and so on. So there's some level of adaptiveness, but there's opportunities for doing that to a greater degree. And the idea, for example, being that the execution engine can learn about what's going on, and then it can go back to either the optimizer or adapt itself, but potentially go back to the optimizer and say, hey, I learned this. Is there a way we can adjust the plan dynamically to make things more optimal given what we know from where we started? So again, this is all open to research and exploration, but I think that's kind of the future for what we're doing.
So this would actually... go ahead.
I think theoretically it could even go towards down to things where you know that certain nodes are just closer to a certain data source and therefore should be used to query from there rather than other nodes and all that kind of stuff. So there's a lot of things that's theoretically possible. I just wanted to point something out that you sort of like brushed over. Not all of our users are that experienced with Presto. And that is in terms of what you said about configuring. So there is operations that you like, there's configurations for the optimizer that you set on a global level in our config.properties where you just enable or disable an algorithm. The next level down is in the catalog file. So in your catalog properties that defines the connections to your data source, you can configure it there. And then the last level down is for individual users, and that's where the session properties come into play. So you have a fine-grained control there.
Yeah. Well, one thing to clarify, I would consider the global and the catalog level part of the same thing. So these are configurations that get set statically when the server starts.
When it starts.
Some of the configurations influence the engine, the core engine, and those are what you mentioned as global. Some configurations are specific to connectors, so they belong in the catalogs. For example, just to give you an example, you may have a configuration that says, don't optimize joint reordering, or always pick this type of join. You can do automatic, or you can say always pick a broadcast join, or always pick a partition join. And that's an engine configuration. But separately, you may have a configuration in the Hive connector that says, don't serve stats to Presto, or don't even try to look up stats or compute stats. So that's also a global configuration for the server, but it's specific to that connector and catalog, because it influences the internal
that's important
behavior.
I think it's specific to that connector and catalogs. It's specific to that catalog specifically. So you can have multiple catalogs that all use the Hive connector. In some it uses that configuration, in others it doesn't, right? So and that's important. So it's really on the catalog level then. So you can adjust to whatever data you're querying there. So it's very flexible. And then the session property is what that means for users is the session is you as a user working in your CLI, and you can set that as a property. And then for your session, so for you as a user, it behaves differently, which of course is like the finest grain because you are the person that submits the query. So you have to potentially have some understanding of what's going on there. Right? So.
Well, and that's a question too, as like, I'm wondering how much, and this is kind of geared towards Martin, is like, how much does a user, let's say there's like the person who administers and was the kind of data engineer type that's running Presto and kind of responsible for keeping its day-to-day operations up and flowing. That person is one person, and then another person is somebody who's like an analyst or anybody who's kind of like running a SQL query or maybe some UI that generates a SQL query, and they pull it in there. They put their query in there. Is that person, does it benefit them at all to kind of have any understanding of the cost-based optimizer, or should it just be a magic box to them?
Well, in an ideal world, I would say it should be a magic box. I mean, we've talked well, not in this context, but in the past we've talked about the goal of Presto is to be like a toaster. You put bread in, you press a button, you get toast out, right? Simple interface, right? But the reality is that things are a lot more complicated, and throughout the evolution of Presto as a technology, there will be instances where Presto is not sophisticated enough to be able to make certain decisions. So we need to leave that to users to do. And that may be a temporary thing. It may be like right now, Presto is not capable of making that decision. Well, we're shooting or we're aiming towards a path where we are going to be able to do that at some point. But as an interim thing, you have control in case the one size fits all doesn't fit your case.
Got it.
Yeah. Cool.
Very cool. This is a great discussion. Do you have any other questions on your end, Manfred, or before we hop on?
I think my head is smoking a bit now.
Right. Did you have anything you wanted to kind of like say, anything more you wanted to say about the cost-based optimizer, Martin, before we moved on to the PR of the week?
No, I mean, you can just keep going with that.
Sure. Okay. Very, very cool stuff. I mean, the cost-based optimizer, I think it's one of those things, like even from my standpoint today, it's just like, it seems it's kind of like machine learning. It's like, it looks like a little magic how it's able to handle all the stuff. But then when you kind of peel the layers back, you get to learn it's not so magical, but it's just, and it has its own limitations and things like that. But it is definitely one of those parts of the architecture that is really fun to talk about. So thanks for joining us to mainly talk about this, but I think I could actually even probably use your help in this PR of the week. So without further ado, PR of the week, we are covering pull request 1415. This is done by Cassia, I think is the right, I don't know if it's Cassia or if, the correct pronunciation, but she's a Starburst engineer and also Presto contributor. And so she really helped me even with understanding this, how this whole thing worked. And to understand this, I think the more interesting part of this pull request, we can actually pull it up just in case we need to reference anything. So the cool part about this pull request, it's the title's Decorrelate subqueries with limit or TopN. And so for some people that might be like a mouthful and you may not know anything about that. So I think it's kind of fun to just hop in and talk about what are subqueries and what is correlated subqueries. So basically to talk about subqueries, when you are dealing with SQL, you'll have, kind of a select from where clause, and it doesn't have to be all those, but just to build up the example, say you have a select from some table, and then where a is greater than some value. And let's say that value isn't just readily available in a column somewhere. Like you have to actually compute that value either from a different table or maybe even the same table. And so this subquery, you can basically, SQL allows you to specify a subquery where you're going to pull back, run this query to basically analyze and pull back a value out of this query, and then that will be your value that could be analyzed within your where clause, and actually answer the parent query, which is like select ABC from table where A greater than some value, and then that value is the where the subquery was done. So there's kind of two types of subqueries that we'll have. We'll have some subqueries that will generate something that can basically be ran on its own, and basically you could run it once and utilize that same value across every row in that parent query. But then there are other cases where, let's say where you would basically take a column from that parent query and use that as one of the criteria in the nested subquery. And in that particular case, we would call that a correlated subquery. And so this would be something where, same kind of query, select ABC from table, and then A greater than, and then you're starting to specify your subquery. But then within that subquery, you specify from the outer table, I want to talk about that table, the column B from that table, and I want to compare it to column B from the table in my nested subquery. So in this particular case, every single row that executes on the parent table now has to compute this, basically run a computation every single time for this row, because we don't know what basically the outer table's column is going to be. So until we're actually at that row, and then we have to recompute that value every time. So hopefully that wasn't too convoluted, but trying to basically vocalize what I'm seeing on a screen here, so that podcast listeners have some understanding of what we're about to talk about. So
Brian, I have one comment for people that, I mean, if you're a programmer, if you know any modern languages, especially functional languages, a correlated subquery is effectively like a lambda expression that captures values from the outer context. So just like in a programming language, that has a lambda that captures things, for every invocation of the outer variables, you would need to create a new capture, right? Mm-hmm. So that's what the subquery does, and that's why it's called correlated. It's like it captures values of the outer query, and then needs to execute in its entirety with those values to produce a result.
Yeah, and I saw we had discussed this before the show, and that was a really good analogy. That's kind of simplifies it a lot. So I totally agree. And then in this particular case, actually going along with your analogy, I'll take it a little further. Is that if we're talking about decorrelating, then and we basically want to see, we basically are trying to see, is there a way that we can kind of take all these values that that could possibly get generated or are generated from this inner query, and kind of basically make those into either like if you're thinking functional programming, kind of an array, or you could think of just like a list of values, or or if it does end up getting compressed down to like even a single value. And so that is ultimately what this particular PR is trying to do. Is it's trying to run a decorrelation on these subqueries. So basically make it to where you can run everything that you'll need beforehand, before you're running the outer query, and that will generate that set of values. And then you from there, you'll actually be able to perform the kind of, this could be either done in conceptually like a join, or it can be you could think of it as more of like just basically pre-computing those list of values, or flattening those values to run in the outer loop. I don't know if do you have any smarter way of saying that, or eloquent way of phrasing that, Martin?
No, I mean that makes sense. It's what we talked about, and you captured it well.
Yeah. Okay. So, but in this particular case, we're looking at limits and a query structure called TopN. And so in Presto, there's no official like syntax that supports TopN, but TopN is effectively equivalent to an order clause and a limit clause put together, because basically what top is trying to do is basically saying, like, give me the first n number of values from this query. And so you can basically re-implement that doing an order by basically ordering the from the first ones that are coming back, and basically saying, give me the first 10 of those 10 of those values. So so basically when we're doing a limit or a limit with an order, then this is basically trying to internally treat these as all top-N queries or order plus limit queries, and basically let them be handled by the same internal node. So to demo this, I mean, I didn't have...
Before we jump, just have to interrupt you for a second there, Brian. Sure. Before I jump into the demo, I think Martin has to rush off, and I think we want to chat about this a bit more. I think it's been awesome for you to join us, Martin. We definitely learned a lot again.
Yep, for sure.
And
yeah, thanks for having me. It's been great, and hopefully we'll be here again soon.
Great. Yeah. Thank you for joining, Martin.
All right. Bye, guys.
Hey.
Going back to the decorrelated subqueries, thanks again. I think, Brian, what we can also consider those is just basically just to understand what the consequence is what it would allow you to do is basically when you have this subquery and it is correlated, you would have to basically, and you return 1 million rows, you have to run that subquery 1 million times, right?
Yeah.
And the aim of this decorrelation is basically to limit that to one run instead of 1 million, which obviously is a lot more efficient. So this is one of those optimizations that makes a huge difference if you can do that. And then when that's the case, unfortunately, because it was correlated before, you might have to do some sort of like temporary data generation, which is exactly what is sort of happening there. So you can explain that more there.
Gotcha. Yeah, I will explain it here in just a second, but let me fix since as soon as Martin hopped off, it looks like your
I got zoomed big time.
You got zoomed in big time. Zoomed you. All right. Here we go.
Cool.
Okay, cool. So we're good. We're looking good now. So yeah, exactly what you said. And one more point, and we're not gonna dive too heavy into this because this is a kind of whole other can of worms to open up. But these also apply for those of you that already know about lateral joins. This is a SQL concept that works very closely. Similarly to decorrelated subqueries. I'm going to leave that to you, those that are interested, to Google about that, and we can maybe cover that on a future show. But this also applies to the lateral joins, as they basically work very similarly to decorrelated subqueries as well. So okay, so let's talk about there's some limitations to what this decorrelating subqueries enabled Presto to do. Let's go through a couple of examples of where this actually runs and works, and then where it fails, and we can talk through each of these examples. So, in fact, let me copy this, because I don't think I even have this in my dbeaver instance right now. And we'll pull up dbeaver, which is talking right now to Presto. And a lot of these were, I pulled these directly from the test. So we could see that this returns basically the values. It basically runs. And that's all this demo is really going to be showing you, is that this actually returns something correctly. Why this is such a big deal is because we have nested within this subquery, we have this limit clause here. And what was happening before is they're just due to the fact that initially Presto thought, hey, we don't know, we have no way of knowing for sure that we can actually take this subquery and make sure that it is going to be a small enough set of, or a small set of values that we can basically flatten. So in some instances, we're able to know, yeah, we can flatten this. Other times, no. So in this particular case, we have the value being 1 and the value being 1 here. Now Presto will basically generate a single value 1 that comes back from this, even with the limit inside of here. And it will, even though the number of values that could get returned from this could be greater than 1, it does this little pre-evaluation to say, hey, I can tell that if I simplify this, or basically by running the optimizations on this, if I simplify this, this actually ends up just becoming values 1, because it's when we basically do this this value where TA equals TB, this is only going to return the 1 value anyways. So I don't have to worry about limit 2 here. So that's why we're actually able to run this. If we were to join on this and we have more than 1 row that gets returned from the inner join, then we actually have a failure. So returns more than 1 row from subquery is the one example. And we're actually going to get a scalar subquery has returned multiple rows in that particular case. Sometime, and so that one, we actually analyzed it. When I say analyzed it, we kind of pre-ran the query, since we're able to basically pull out some of these values, and we were able to see, hey, we were able to actually get this this set of values, or this basically determine how many rows is it possible to come from this subquery. And basically, based on that determination, we knew, hey, this is going to have a possibility to have more than 1 row being returned. We're not sure if we can flatten this, and so we basically disable this from being an option for a subquery, because we don't know basically how this could impact the performance. Okay, so let's go on to another one that we again know we can run now with this PR that's been done. We're now down to limit 1. And anytime, even though this would join with 2 of these values, again, where TA is equal to T and T equals to T2.A, we know that this should be able to run, because this basically will return of more than 1 value based on this T2.B greater than some constant. And actually now, I thought I had understood this a little bit better, this particular example a little bit better. This one runs. The time where it doesn't, where it fails actually, is where we're dealing with, I'm guessing, and you know what, now I know why it does, because these 1s end up getting flattened into a single value, but then the B here, even though they are not getting flattened into a single value, we only project the A here. There we go. So that is why in this particular case, we were able to run this. Let's go down here where we're actually running, we're invoking TB now, and we actually have this 2 and this 3. If we run this, there's going to be a non-equality predicate in the subquery, which is greater than. We run this, and we actually project TB, and we're going to say the given correlated subquery is not supported due to the fact that we have this non-equality predicate in there. So let's do the last one, and then I'll have a couple words to say about this. So the last one is that TopN query, where we have both order by a particular column, and then we limit it. Let's go ahead and run that. We see that this one also runs. And similar to with the order by, this is yet again similar TopN on the non-equality. It's just the same as the last one that I had just covered, and that one fails because, again, we have the greater than comparison between T.B and T2.B. So the thing that I want to kind of mention about these is that there are, anytime in general that we are not quickly able to determine that the subquery is going to be returning more than 1 set of rows, and we don't have the ability to flatten something, then we basically are limiting Presto from being able to compute that due to potential performance implications there. So that is something that I thought was very interesting. Just to get an understanding about how some subqueries work, as also how to understand how they work with the planner, and then just to kind of understand if you do run into this, you'll have a little bit more of an understanding of, oh, okay, so perhaps this subquery has potential performance implications, and that's why we're not actually able to run this correlated subquery. So I have a lot more specifics about that and what this basically what we're doing here in the pull requests up here in the notes. But yeah, Manfred, did you have any comments or do we have any questions about that in the chat before we head on?
No, there's nothing in the chat. I think I just find it's quite interesting how like a simple looking query can by just like little changes actually be something where it doesn't make sense versus it does make sense.
Yep.
And that's kind of cool. And I think in the the more complex aspect of that would be to like actually get to a stage where it does run it up front and then have some sort of like cross lookup with a cache table and all that kind of jazz.
But then with that, you have to, how do you, so this is kind of getting back to that, involving the user into the, there's performance implications here. So do you just throw an error like we're doing today, or do you, make some, essentially the answer to this would be, you could allow the user to then overwrite that functionality in some way so that they say, hey, okay, I know there's going to be a performance hit here, or potentially a performance hit here, but I have to run this query, or else Presto's useless to me. And so in most cases, this is really getting into the nitty gritty of like where order and limit, getting added to a nested subquery. So most likely there are other ways around it depending on how your query is set up. And if you do run into these cases where you're hitting these walls and you're talking where and limit, and you all of a sudden you get this exception getting thrown, at that point definitely come to us, and perhaps there's a way that you can restructure your SQL or get the answer in some other way. And then if it becomes a big enough thing, then maybe it's something that you or somebody in the community could implement to kind of be that that kind of, okay, set this property and then now it works, but it could take forever to run. So very cool stuff. Let's wrap things up here with the question of the week. This isn't a very one that needs a lot of explanation, I don't think, but it is one that we get asked a lot when people are new to the community. So, will running Presto on my relational database make processing faster? And so let me see if so this is an actual quoted version of this of the simplified version of that question. I've been going over the docs of Presto SQL, seems to fit some of my requirements. I'm a little concerned about resources needed to run Presto in production, and because the size of my prod data is 3 to 5 gigs, and there's going to be very minimal data growth. Is Presto suitable for such a small data size to be running on a relational database like Post? I think Postgres was the particular example here. And so, this particular person kind of already had the idea coming to us, like this is probably useless to pull Presto out for a 3 to 5 gig database that has that already has a lot of.
Yeah.
Oh, okay. So that already has this kind of very tested and true relational database that can have all sorts of indexes and have all sorts of optimizations of their own to return these queries fast. So the general gist that I want to kind of cover is, like, when you think about Presto, the things I get most confused about it is, it's not a database. We don't store our own data, so we do connect to source to other databases to actually pull from them. It's not developed for OLTP workloads. That's another very common one. But then the final one, it's like, we're built to handle scale of terabytes of petabytes over distributed querying. And that's where Presto really shines. If you are dealing with smaller database kind of workloads like 3 to 5 gigs, and Presto has no magic solution that when you put it on top, it'll just magically make things faster. You're probably going to want to go through typical kind of traditional tuning methods. This could be index tuning, and this could tune to a specific query, or it could be tuning the system itself in general for Postgres. At that point, you want to kind of like look at, can I beef up if I know that it's going to be 3 to 5 gigs, could I just basically throw 10 gigs of memory at this instance, and basically at that point probably never run out when I'm running queries, depending on how much your query load is too on this database.
Basically running this an in-memory database. That's totally.
Yeah, and then you're gonna get it super fast at that point. So the basic answer to this one, and we finally have you could say it depends, because that's usually our answer to all of these.
That is my answer, actually. I was gonna say really okay. So if the limited question is, can you query the database with Presto, and is it going to be faster? Then the answer is probably no. But in most cases, that's not actually what you want to do. In most cases, you want to go, well, actually, I want to query that database, but I also want to link it to these log files in Hive, or link it to Elasticsearch. And then it is a totally useful use case to use Presto, because you can actually do that without working with APIs and mucking around. You can just do it in your SQL. And then it is not necessarily faster to query your relational database, but it is faster than any other approach to get all the data from the different data sources plopped together.
Yeah.
And then it's totally a useful use case. Right?
Yeah, if you're trying to basically, as soon as you need to join one database in one, let's say zone or sector or system, and you have another database that you want to join, that immediately validates the Presto. The other one is if you are, the one kind of, let's just say if you're just doing I have one database and I need to swap it. If that database is, Hadoop, Hive running on Hadoop, then in that case, yes, you can. If you swap Hive runtime with Hadoop or Presto runtime, then that's going to be faster. That's going to be that was initially the base case reason of Presto being created, and then it scaled out to this, because it was architected the way it was. You were able to have this nice federated use case as well that fits a lot of people's needs. And so, whether you're trying to do fast querying over your S3 or HDFS, is that one, you always use Presto. If you're going to be trying to do federated querying of any sort, definitely use Presto. If you literally just have a single database, which I don't know, maybe you're just a startup and you just have one single database to run your whole thing, and it's 3 to 5 gigs and it's not going to grow, that particular case, then you're probably going to want to soup up your Postgres or your MySQL or your whatever SQL database, traditional relational OLTP SQL database that you have running. So
one thing that I always what I actually find interesting about this also is, I think there's some interesting edge cases where it kind of gets into imagine you have a large, really massive relational database that runs on one server, and that server is pre-text in terms of processing. If you throw Presto on top of that, it would open multiple connections to that one server, read the data via multiple nodes, and then do a lot of the downstream aggregation and that kind of processing within Presto. Theoretically, it might be possible to actually get faster with that, but practically what often happens is that Presto actually can get to a stage where it can flood the underlying system, because it opens, if you have a large Presto cluster and it really tries to go parallel a lot, it can produce a significant load on the poor single database that tries to serve the traffic, and Presto is just give it all to me at once, right?
Yeah.
So
it makes me wonder.
Kind of interesting, right?
So there's I think one of the original use cases at Facebook was they were doing those distributed MySQL things, right? I think they had distributed MySQL, whatever.
Yeah, it's called sharded in the MySQL world. So they have this where it's multiple.
So if you had something like that, then probably, if you're and if you're talking about one single box, I still think most of the time it's going to be no. But if you're talking multiple boxes, and you can do sharding, It's also what they call it in Mongo.
Yeah.
So, but yeah, if you're doing sharding and you have some way to basically distribute how Presto can interact with your your database, even though it's one database, it's interacting with another distributed database at that point. But I don't know if that's even possible, like for configuration and stuff like that.
Like I know that the Elasticsearch connector can, for example, do that. Like it can talk to Elasticsearch cluster and figure out data local-wise which node in the cluster to talk to, and it will just talk to that one, get that data, talk to the other one, get that data, and so on, and actually be super fast doing it that way, right?
Yeah, so it starts bartering with the master, and then the master is just like, hey, this is the node, and then from then on,
over there,
that IP address, and so you can just talk directly, because every single Elasticsearch cluster is all unless you explicitly turn that off, every single node in an Elasticsearch cluster has the same port open as the master cluster does to do those queries. So cool. Yeah. I mean, there's always
quite
an
fun, right? Like it's exactly right. So.
Always it depends, but then like I would say in this constrained case that we used as an example, and you're dealing with one box. Yeah, it's totally overkill. So, but we're biased to say that in general, for all sorts of cases, you should just use Presto.
Exactly.
Cool. Well, with that being it, is there anything you wanted to add before we end the show, Manfred?
No, I just want to say thanks for joining us in all these last sessions. We'll be doing more in the next year. So join us again for various events. We'll be running the Presto Community Broadcast next year, and we'll have a lot of fun with you all, hopefully.
For sure. One last thing to remember. Yeah. So as Manfred mentioned, it's in the next year. So we will be skipping the day before the new year, which is December 31st. So that would have been the day we would have been doing this next show. But we decided we wanted to take a holiday. We probably want you to take a holiday. Everybody needs a break because of this crazy pandemic. So let's all take a break, and we'll see you guys a couple, I think it was January 14th. We will see you at the same time, same bad channel. Music for the show is Mega Man 6 gameplay by Krzysztof Slawikowski. That's also in the show notes. And thank you very much. We'll see you next time.
Thanks, everyone.